All right, welcome to the first of its kind, world-changing manufacturers network. Lisa Ryan has her ears to the ground and her heart in the game. Get ongoing education and new connections right here with Lisa and the Manufacturers Network. Buckle your seat, listen, and spread the word. Here's Lisa.
Hey, it's Lisa Ryan, and welcome to the Manufacturers Network podcast. Our guest today is Prateek Joshi. Prateek is the founder of Pluto Shift and a published author of 13 books on AI. He's been featured on publications such as Forbes, CNBC, TechCrunch, and Bloomberg. And you can also visit his website at prateekj.com to learn more about him. So Prateek, welcome to the show.
Thanks, Lisa, for having me. It's great to be here.
Tell us a little bit about your background and what got you both interested and involved in AI.
Yeah, I grew up in a small town in the southern part of India. Growing up, water was a bit of a luxury, right? What happened was, just growing up, we didn't have it. So it stuck with me. And as I began my professional career, I studied machine learning, AI, a natural inclination. But really, when it comes to AI in the physical world, there's a big gap. It's not nearly as ubiquitous as it could be. Like search engines, we all know it. We use it every day. It uses machine learning a lot. But when it comes to the physical world, there's a big gap. And so that was the core motivation behind doing this is to bring AI to the physical world. And it started with water, meaning any physical infrastructure that touches water, it gathers a lot of data. And then how can we use a tool like AI to solve a very important problem like water, right? How can we use it efficiently? How can we distribute it? How can we make sure it's not wasted? So that's how it all started.
Wow, that's so interesting. So what are some of the applications of water that AI would be used for? It's something that I would have never even thought of.
Yeah, no, it's a very interesting topic. And so a simple example, right? So here in America, as the people like average consumers, we get our water through a network of pipes. And a very important part within that setup is the cleaning process, meaning you get raw water from somewhere, and there are these very big treatment facilities that convert raw water into water that we can consume. And this is actually a very energy intensive process, meaning you need to use a lot of electricity and chemicals to make sure water is clean. And if you're not careful, then the water can leak, you can waste electricity, which is again a very big problem. So a simple application is collect data such as pressure, temperature, flow rates, and then use a tool like AI to make sure you're not wasting water. You're not letting it leak somewhere. You're not wasting electricity to treat water. So it's just one application of how you can use AI in a very practical way. There are 100 other use cases as well.
Wow. So when it comes to manufacturing, because of course water can play a big role with a lot of manufacturing plants too.
Yeah.
But as far as really taking this into the manufacturing sector, how do you make AI practical for manufacturers?
Yeah, when we look at a manufacturer, a simple example would be a company that produces food or beverage. What they have to do is, part of the process is they have to get raw material. Like let's say you're making ketchup, and you got to get your raw material in, and then you need resources such as electricity and chemicals, water, basically that goes into it. And so raw material plus resources goes into the facility, and then the ketchup comes out. Now, this can be, if you look at a manufacturing operation, this can be broken down into a number of steps. And each step can it has a certain level of efficiency, meaning how much are you consuming to produce a unit of output. Now, if you don't use any technology, a human would have to do it. Meaning, imagine a facility where you have 300 membranes, like it's a filter, and stuff is flowing through, and you got to make sure it's all functional. As a human, you can't keep an eye on such large infrastructure just by kind of running around, right? So the goal is, how do we make sure that if, let's say, membrane number 49 is acting up, how will you know, right? It's a simple example of how you can, if let's say the pressure is going way up or it's going way down, you need to know. You know, in the COVID world, you'll be sitting inside your office, you won't even know what's happening. So that's where a technology like remote monitoring can be very useful. A tool can automatically detect, okay, membrane number 49 is acting up, you need to do something about it. So what this does is it makes sure that physical product, they get produced on a very regular basis, and you don't need to kind of run around to make sure the system is working perfectly. So that's just one example is production. Supply chain is another very big area of a whole bunch of use cases. But yeah, I think operation-specific use cases can be deployed very efficiently here.
So let's go back all the way to Artificial Intelligence 101. Because since you've written 13 books on it, obviously you're the expert, so I can ask you questions like this. But take us way back, like what exactly is artificial intelligence and what does it do? How does it work?
Artificial intelligence it's a state, right? It's a goal, meaning you can build a system, you can build an AI system that is intelligent enough to take actions on its own. Now, that's why. So AI is a state of being. Now, machine learning is a vehicle to achieve that goal, right? And data is the fuel for that vehicle. So that's how we relate these terms like AI and machine learning and data. That's how they fit in together. And so when we use the umbrella term artificial intelligence to describe any system, hardware or software or a combo that can do things on its own, we use it every day. The simplest form of intelligence is like a calculator, right? It's very simple, but we don't think of it as AI, but technically it is doing a little something, right? You add two very big numbers, it shows you the result. More complex AI systems can drive cars on their own. They can, when you're flying in the air, they can detect danger. So it ranges how much intelligence we can put in a system, but that's how we look at AI. And today where we are is we have seen very successful implementations of AI in the form of like automation, meaning if you're in a factory, sometimes it's very dangerous for a human to approach a hot furnace. So there's a machine that does a specific task of taking this and putting it there, and it does it on its own. So it's a simple example of how AI manifests itself in the real world.
And so AI then would be a part of machine learning, because if I'm hearing you correctly, machine learning is the machine is doing something and over time it learns from itself and it gets better?
Mm-hmm. Yeah. So machine learning is, machine, as more data comes in, the machine learns how to behave in a variety of scenarios. And then obviously, as it learns more and more, it approaches true AI. Obviously, you'll never fully, the goal is, as of today, we are not fully there yet. So we don't have like an AI system that's indistinguishable from humans. We're not there yet. But systems are becoming more intelligent, and machine learning is basically all the algorithms. The umbrella term is, machine learning is that, all the algorithms and tools and frameworks that you use to make a system intelligent.
So what are some of the ways that you would deploy some of these AI technologies in the world of like a physical infrastructure?
A good way to look at it is we work backwards from the use case, right? And let's say, I'll take a simple example. Let's say the goal is to reduce energy consumption. Let's say you are a food processing company and you want to reduce the energy you consume per unit of output produced. Now that's a problem. Once you've identified that goal, then you work backwards to figure out, okay, what tool or what system should I use to attack this problem? Because AI is pretty vast. There's no universal single model that can solve everything. So working backwards from problem, and then you do that. And then once you define that, you also make an assessment of, okay, what data do we have available? Meaning we want to reduce energy consumption, but do we even know how much we consume today? Like, do we know the initial primary levers that make the energy consumption go up and down? Like, are we even collecting temperature data, right? So these are basic questions. So and then okay, we have some pressure, temperature data, we know what we want to do. Then you build a tool. It could be software, it could be hardware, it could be both. And then together, the whole thing, it starts driving that. Today you consume X, maybe 3 months from now you'll consume, zero point 0.8 of that, meaning 80% of that, and then eventually 50. And then so the goal is to, in an iterative fashion, drive towards that goal, and that's how AI appears. So over time, it always improves with more data.
And so if somebody's thinking about incorporating AI, incorporating machine learning into their plant, what would be some of the ways to drive the behavior change that's needed for that implementation? Because obviously, people are going to be afraid they're going to lose their jobs, or they may not like the robots, or they may be afraid of them, or they have all these misconceptions as far as what AI can do. But starting with that conversation and starting to change the employee's behavior so that you do get the buy-in you need.
Yeah, we commissioned a study just to understand this, right? So as COVID hit in March of 2020, and then a few months later, we just wanted to understand people in the world of manufacturing. Could be operations managers, operators, directors, people who are running facilities. We just conducted a survey of those professionals just to understand, how do you use it? Because clearly you can't go into the facility every single day, and yet you need to know everything that's happening at all times. So what are you doing? So we conducted that survey, and we found out very interesting results. It's not that people, companies, they do attempt a lot to do digital transformation, meaning if you're doing pen and paper, how do you digitize that work so that you don't lose it in a fire or something, right? So the goal is, how do you digitize the operations? And 94% of the participants, they said that their company's primary way of doing it is boiling the ocean, meaning somebody comes up with a big initiative, the entire company of 40,000 people, they try to do everything all at once. And in many, many instances, it's just not a feasible thing to do, because you're a very, very big company. Introducing a drastic change, it never sticks. And that's why boiling the ocean shouldn't be plan A, and yet people do this. And within that, 78% of the participants, they said that they were supported by the department heads when they took an op-specific approach. What I mean by that is, you choose a piece of work, could be like monitoring a membrane or detecting pump failure, or basically like a small piece of work, and then you transform that, you digitize that in a very focused manner, in a bite-sized way. And what that does is it creates a success template, meaning, this facility in Los Angeles or this facility in Miami, they did it. And so that template can now be implemented in Chicago and Austin, right, and Seattle. And what that does is this groundswell, it builds up, and then that's how you transform a particular piece of work into and digitize it. So what we call op-specific digital transformation. So I would say start with a bite-sized approach, create a success template, and then that can be used to actually transform work. So that's what we have seen. It has succeeded quite a bit here.
Is there a best practice as far as deciding where to start? I mean, are you looking for the most mundane tasks that human effort is kind of being wasted on? Are you looking at the most dangerous tasks? Are you looking for those really detailed tasks that maybe humans miss the mistakes? Is there some kind of best practice that you recommend?
Yeah, that's actually a very, very good question, because what happens usually is that initial choice kind of determines the entire approach, meaning people are either completely turned off by it or they become very enthusiastic about it. So the initial choice matters a lot. And what we have seen is, pick a workflow that is like a low-hanging fruit with high impact, meaning something could be really easy, but if the company doesn't care, then the initiative will be killed. So the goal is to figure out what is a low-hanging fruit that can have the highest amount of impact on the business. And that is the great first choice. So you do that, you automate it. When it comes to bringing a new piece of technology, it has to make sense for both the user, meaning it has to be easy to use, and ROI wise, because a company has to invest capital and they need to see the return. So the sooner you can make that happen, the better it is. So because of that, I think this combo using, like a simple example would be monitoring as a simple example, or other examples could be if you are scanning receipts by hand, right? Digitize that, because nobody wants to sit and do that. People have other work. So the goal is to identify those tasks that nobody's going to miss, and yet it's going to have a big impact and go after it.
So with the clients that you've worked with and the study that you've done in this field, do you have some examples or success stories that you can share of kind of where the company was before and what happened after they started using AI?
Yeah, we have a very good example of a company where, before we started working with them, obviously they produced the beverage company, they produced a product, and what was happening was water is obviously, as you can imagine, is a very important part of the business, meaning how they source it, how they treat it, how they use it, how they discard it. All of that matters because every incremental benefit, basically every incremental piece of efficiency is going to translate to real dollars because it's a very big company. So because of that, within their operation, water treatment was a very big part of it. So we started working with them on that. And what happened was over the course of a year, we ended up saving more than 15 million gallons of water. That's just at one site. And if you can just imagine, 15 million gallons can feed a family for years. It's a lot of water, right? And so at industrial scale, it's obviously they produce a lot. So the goal is identifying these high impact areas where before us, they're doing this. After using a product, they started doing that, and then they ended up saving this water. And now, what that also does is, in addition to the ROI benefit, there is a positive impact on their ESG metrics, carbon footprint, right? So that is another very key benefit that you can achieve by solving problems in energy, water, chemicals. It can have a big impact on your ESG footprint.
And are there particular types of industries that you've mentioned beverage a couple times, and you've mentioned your connection with water? What are some of the other big industries that you've seen that have really successfully taken off with this? Yeah,
the trend we have seen is any industry where the energy consumption is high. That those industries are really they're very active. They actively pursue new technologies because it's a very expensive resource and it has a big impact on carbon footprint. So I would say water, beverage, food processing, chemical manufacturing, data centers, and CPG. So these industries, we've seen a lot of activity in these industries. Obviously, food and beverage has been very active. So I would say that's one of the most active verticals. But yeah, all these industries have been very actively pursuing new technologies here.
Any other ideas or tips or anything, if somebody's starting to think about this, some resources maybe they could turn to, what would be the best way for somebody to even start exploring the topic?
I think a lot of the resources are available online. Obviously, on our website, flutoshift.com, we have a number of white papers and case studies that we have just published, mostly talking about how to think about it. But in addition to that, I think a lot of the publications, depending on the industry you're in, like Smart Water Magazine publishes water-related technologies. Food and beverage, they have something similar. Chemical industry has something similar. But I think at the end of the day, the goal is to kind of try things out, create a framework where you can quickly try things without disrupting the business and see exactly what works for you. And for that, I think what you need to look at is simple things like what can we automate, right? That's a very easy starting point because there's always something we can automate. There's something as simple as scheduling. We automate that, right? So it makes our life easy. So within manufacturing, you can just look at, can you automate the work of monitoring your memory? Can you automate the work of ticketing, right? What happens after ticketing? What happens before ticketing? What happens when you do save energy? How does that get reported? So basically, kind of figuring out what can be automated is step one, and then after that, working with a partner who can do a small, well-defined pilot and go from there. So I think that's a good way to get started here.
And is there a way to test that it's working? Is this something that once you make a commitment to AI, you're all in or not? Or is there a way to test it, see if it works, and then decide, yes, I'm going to stay with this, or no, I'm going back to the old way?
100%. I think testing matters a lot, and that's exactly how we should think about it. So as a new technology, the goal is, let's say you are a director of operations, the goal is you got to create a framework where if you want to test out, let's say you saw a new AI cloud tool that can reduce chemical consumption, right? So the goal is how can we quickly test it out? So it usually takes about 90 days. No matter what piece of tech it is, within 90 days, you should be able to see the impact, right? Nothing should take like 2 years. That's too long. I've seen 90 days as a good time metric where you deploy it, you use it honestly for 90 days, and then you measure before versus after, meaning you have to be diligent about what was the status quo before you started doing it so that you can actually measure the impact. And then you can do it. And again, it's not a one and done thing. It's like AI is it's becoming as ubiquitous as cloud or internet. It's already here. The goal is just to kind of make it work for you. It's ubiquitous. Almost all of us use it every day in some shape or form. It's just the goal is to figure out how to make it work for you.
And what about tying it in with your existing systems? You think that there are some manufacturers that have equipment that is decades old and they're trying to incorporate some new equipment, or is it better if you're just starting fresh? I mean, how difficult is it to tie in all the different systems that you're going to find in a manufacturing plant?
Yeah, that's a very legitimate concern that when we talk to our customers, potential customers, we do see that quite a bit because these companies have been around for decades, or some companies have been around for more than 100 years. So they have a long history of decisions and obviously associated hardware. So the goal is to make sure that they stay up to date on so simple things like data collection, right? So if they're not collecting data, step one is to get the sensors in place, start collecting the data. But yeah, I think if you map the journey, there are people on all parts of the spectrum. If you have nothing going on, step one would be talking to a hardware company who can deploy sensors and send the data to a database. Once you have that, then you go to the next step of data analysis, right? You don't do data analysis without any data in place. So I think assessing where you are on that spectrum and then choosing the right initiatives, it matters a lot. And I think many companies are successfully moving along the spectrum. They're moving fast, and many vendors and companies are showing up with amazing technologies.
And then the last thing that comes to mind is just from a security standpoint, from a cybersecurity standpoint, how are you making sure that all of this is being kept safe, that nobody's able to access that or hack into your system? What are some of the things that you would recommend as far as that goes, or is that not an issue?
No, it's definitely an issue. So any data company has to, obviously, in addition to your own security, you also have access to your customers' data. So you have to absolutely make sure that data and your system is secure. And for that, there are a couple of very important applications. Basically, a third-party auditor comes in, conducts the audit, and then they certify you. It's a pretty long process. But SOC 2, Type 2, is basically, it's one such. It's very stringent. Every data company that that has signed big deals, they have it. ISO 27001 is the other one. So basically, between these two, they're very stringent, I would say, audits conducted by auditors. And after you pass it, it's fair to say that it's pretty robust. And on top of that, obviously, you have to have good practices installed inside the company so that as new teammates come in, they're trained on cybersecurity, they know what to do, they know what not to do. And then you make sure that you have those systems running. So the audit is every year. It's something that as companies consider working with other companies, this kind of tells them, okay, I can partner up with this company because there's an audit in place.
All right. So as we're getting to the end of our time together, is there anything that we didn't cover that you think is important for our listeners to know?
I think we covered a lot of good topics. One thing I'd like to share before we end, I think as people are looking at building technologies, working on new initiatives, I think it's kind of important to find your core purpose for any initiative, for any piece of work, for anything that you're doing. What it does really is it helps you work from that purpose. Meaning the purpose is not to, in this case, for example, the purpose is not trying out AI. That's not a purpose. The purpose is how do we reduce water wastage? How do we increase energy efficiency? How do we not waste chemicals? How do we make sure that food is not wasted? So basically, I think that core purpose, and then working back from that, you choose the tools that work for you, like find that Zen that works for you. But I think it's very important not to, AI is, at the end of the day, it's a tool. It's a tool to make something happen. And I think it applies to career, building products, or life in general. So I think that's something I follow.
Yeah, no, that makes a lot of sense. Well, Prateek, it has been just a pleasure having you on the show. If people do want to get a hold of you and continue the conversation, what's the best way for them to do that?
To get in touch with me, feel free to email me at prateek@plutoshift.com. And if you want to learn more about me, you can visit prateekj.com. And I'm happy to continue the conversation.
All right. Well, again, thank you so much for being on the show today. It's been great.
Thanks, Lisa. Great chatting with you.
I'm Lisa Ryan, and this is the Manufacturers Network podcast. We'll see you next time. Thanks for listening. Hey, do me a favor. If you like what you've heard, please subscribe and give us a 5-star rating. Also, feel free to share the podcast with your friends and colleagues so we can grow the network and connect more fantastic folks just like you. You can either go to the website at manufacturers-network.com or share the podcast on your LinkedIn, Facebook, Twitter, Instagram, or wherever you and your industry friends hang out. The bigger and faster we grow this network, the stronger and deeper community we will have. I appreciate you. Thank you.